Whenever we look at classifying quadrilaterals, we look at our quadrilateral tree that kind of sorts out the direction that we go for the shapes and the properties that come with each. So we first can start with our parallelogram. In a parallelogram, the definition is that both pairs of opposite sides are parallel. The following four properties all apply as well. Both pairs of opposite sides congruent, both pairs of opposite angles congruent, consecutive angles are supplementary, and that diagonals bisect each other. Now, this applies for a parallelogram as well as every shape within the parallelogram tree. So a special case of a parallelogram is a rhombus, and that is when it's a parallelogram with four congruent sides. Also in a rhombus, you have the diagonals are perpendicular and that the diagonals bisect angles. A rectangle is also a special case of a parallelogram. That's when you have four congruent angles, which would also be right angles, and diagonals are congruent. Lastly, we have a square. A square doesn't have any new properties, it just must have a property from the rhombus category and the rectangle category to qualify as a square. Then we go over and we look at our trapezoids. Trapezoid starts off with the definition of one pair of parallel sides. That's what makes it different than a parallelogram, where a parallelogram has to have both pairs of opposite sides parallel. Now, if a quadrilateral doesn't have parallel sides, it doesn't mean it has to be one of these, it just means we call it a quadrilateral. Now, a trapezoid also gets same side interior angles, and that's really from the parallel sides. So when we look at these two angles are going to be same side interior, so they're going to be supplementary. Now, it doesn't necessarily mean that across there's a relationship. That's something we get to with the isosceles, but it is true in a trapezoid. The mid-segment of a trapezoid is if we draw a line that connects the midpoints. This mid-segment is the average of the two bases of a trapezoid. So it's not really a property, it's just a way we can solve for parts of the trapezoid. Lastly, we have the isosceles trapezoid. Now this is going to be a trapezoid where the legs are going to be congruent. Now these are what we identify as the non-parallel sides. So these would be the legs are congruent. You also have the base angles. So if we had congruent legs, the base angles would be the bottom two here, or the top two. Those are also congruent, and as well as diagonals are congruent. So if you notice, diagonals congruent appear for both of these. What makes them different is the number of parallel sides from the shapes. So now what we're going to do is we're going to use these properties, which we've kind of all put together, and go through and look at shapes and figure out the best fit for them, and then have justification to why that shape works. So our first one here, if we look, this is going to be a parallelogram because we have two sets of opposite sides parallel, or both pairs of opposite sides parallel. Our next one, we have parallel, 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 and then congruent. This would also be a parallelogram. And you could do the same reason as we did here, both pairs of opposite sides parallel. There was also the reason of if one set of opposite sides are congruent and parallel, it's a parallelogram. So that one would also work for the justification. So two ones there. The next one we have was we have four congruent sides and four congruent angles. So first off, we know that's a parallelogram because it has opposite sides congruent, or opposite angles congruent. There's a few ways. We know it could be a rhombus because it has four congruent sides. We know it could be a rectangle, so it has four congruent angles. So when it's both a rhombus and a rectangle, we call it a square. And our reason would be there's four congruent sides and four congruent angles. For our next shape, we have same side interior angles here. Are supplementary. So if this is 90 and this is 90, they add to 180, which makes it parallel. So this will be a trapezoid because it has one set of parallel sides. Moving down, next row here, we have a pair of congruent sides, just one pair. If that's all we have, it's not a parallelogram, it's not a trapezoid, we're just going to call it a quadrilateral. Nothing else qualified it, so we just stay at the top classification. For our next problem, we have 115 and 65 as pairs of angles. Now, these add to 180, which gives us parallel sides, as we also have here. So the trapezoid we get from the parallel sides, but we call these base angles. So this would be an isosceles trapezoid, because base angles are congruent. Our next shape, we have 4 congruent sides, so it could be a rhombus off of that. But if we look, we have 3 right angles, 90, 90, 90. Now, we know in a quadrilateral the angles add to 360 degrees. If this is 90, 90, and 90, that would be 270, which only leaves 90 left over for right here. So if that's the case, that would also be a right angle. So now there's 4 congruent angles, and this is a square. For our next one, we have diagonals are perpendicular. We have diagonals bisect each other because of the markings here. But not only do they bisect each other, because their markings are all the same, we have that the diagonals are congruent. And since that's the case, the diagonals are perpendicular, you get a rhombus. Diagonals congruent, you get a rectangle. Because it has both, we're going to say it is a square. Moving down, I have 1 set of parallel sides, which makes this a trapezoid. Then I have 2 congruent angles. We're going to call those base angles. So I have parallel sides and base angles congruent. This will be an isosceles trapezoid. For our next shape, we have diagonals that bisect each other. So that qualifies as a parallelogram. But also, because these markings are the same, this tells us that the diagonals are congruent. So we'll say diagonals bisect each other. That makes it a parallelogram, and they are congruent, which goes a step further to make it a rectangle. This next one, it's very similar to what we did right here, where we have the base angles congruent. So this one, congruent, parallel sides and base angles congruent, same reason. This would be an isosceles trapezoid. For our last one, we have 56 and 124. They add to 180, so this gets you parallel sides. So 1 pair of parallel sides. If that happens and we don't have any base angles or legs congruent, we're just going to call it a trapezoid. For the back side, we're going to do the same thing now. We have kind of faint markings, but we have sides here, here, and here. Looking at that, that tells us both pairs of opposite sides are congruent. And that's going to make it a parallelogram. For our next shape, we have that diagonals bisect each other, but they're not congruent. So diagonals bisect. That makes it a parallelogram, but we also add the right angle that the diagonals are perpendicular. If that happens, if it's a parallelogram with perpendicular diagonals, we're going to say it is a rhombus. Next problem, we have opposite sides are parallel, both pairs. We also have diagonals bisect each other, which still falls in the parallelogram category. What happens here, though, is that diagonals are congruent. So since diagonals are congruent, so it's a parallelogram with congruent diagonals, that will be a rectangle. And last one, 1 set of parallel sides, or 1 pair of parallel sides, tells us it is a trapezoid. Now, these appear to be congruent here, but we do not know if the legs are congruent. We'd have to have something labeled. That's enough there to just say trapezoid. So now in this last part with the box is we're going to find where properties apply and what shapes they work for. So a good example of this is we start with the first one, both pairs of opposite sides congruent. Where that comes in on the table, it applies to that shape and any other shape within that category. So both pairs of opposite sides congruent is a parallelogram. If it works for a parallelogram, it works for a rectangle, rhombus, and a square. It does not work for a trapezoid or isosceles trapezoid. Both pairs of opposite angles congruent is from a parallelogram. If it works for that, it works for the other three. Exactly one pair of opposite sides congruent. Now, a parallelogram in all of its shapes have two pairs of two pairs of opposite sides congruent. That only is going to work in an isosceles trapezoid. That's the legs of the trapezoid. Exactly one pair of opposite sides parallel. These need two pairs, so exactly one pair will be a trapezoid. If it works for a trapezoid, it works for an isosceles trapezoid. Exactly one pair of opposite angles congruent. So since it's exactly one, in a parallelogram it's both, so those are out. Opposite angles are not congruent in these two, so that's also out. So none of these have this property. It doesn't mean it's not possible. I could draw a shape to that, it's just not one of these six. Consecutive angles supplementary. That is a rule in a parallelogram, so it works for the other three. Now, technically you have some consecutive angles supplementary in a trapezoid, it's just not all. And we're not going to say that rule works, it's just a slight exception because we know we have same side interiors, so these two, but not necessarily those two. So it's important to know the difference, so that's why those are left out. Do they have supplementary angles? Yes, they do, it's just not all of them. Diagonals congruent. Diagonals are congruent in a rectangle, which means they're also congruent in a square, because it falls under that. It also shows up in an isosceles trapezoid. Diagonals are perpendicular. That is a property that fits to a rhombus. If it works for a rhombus, it automatically works for a square, and that's the only one